in this problem, we have a 30 kilogram reel mounted on a 20 kilogram cart, and it's pulled by a cable at 50 newtons as shown here. Okay, so I want to determine the velocity of the cart as well as the angular velocity of the reel after 4 seconds. The radius of gyration on the wheel is 250 millimeters. So start with the wheel, or the reel, excuse me. Draw a free body diagram. So I've got a pin at O, and then I have the 50 Newton force as well as gravity, 30 times 9.8. Okay. The moment of inertia of the reel is 30 times 0.25 squared, radius of gyration. Okay. So then applying my angular momentum equation, I have an initial angular momentum, which is 0. It starts at rest. A moment about g. The only thing creating a moment about, well, g or o, it's the same thing, about the center here is the force P added there. So I have 50 times 0.15 times 4 seconds. Okay, and that's going to equal the final angular momentum, which is I omega. Okay, solving for omega, I get 16 radians per second. Now to find the velocity, I just do a linear momentum equation. Okay, again, it starts from rest, mv. Okay, I've got a 50 Newton force times time, which is 4, and then I have the pin joint here, OX, times 4 as well. And that's going to equal the mass of the reel, which is 30, times its velocity. Two unknowns here, right? I've got OX and I've got V. So I'm going to look at the cart as well. So I've got the same OX, OY, Newton's third law flips them, weight, normal force. Again, trying to figure out OX and the velocity in the x direction. So I'm going to do the impulse momentum equations in the x direction. So again, I start at 0, no momentum. Then I have the force. Now the only force acting on this cart is OX, right? Because the force P is only on the reel. So I have OX times 4 seconds, and that's going to equal the mass, which is 20 of the cart, times its velocity. So I've got two equations, two unknowns here. I've got V and OX, so I can solve for V from that, which is 4 meters per second. So the main thing here is to recognize that it's a vector equation, so I have both linear momentum as well as angular momentum, and I can do it. I can break it up into different parts and do them that way as well. So there you have it, rigid body impulse momentum.